Hello students, let's see the next problem, projection of hexagonal prism with just one more faces added to a pentagonal prism. So in this case, prism side length is 25 and the axis length of the prism is 50 mm, rest on HP on one of its corners of the base. So this is the first step. Step is prism hexagon. By default we are going to keep it on HP as per syllabus and rest on corner, and corner should be on the right side when you are going to solve the solids. So as per this question, so we are going to be taking the hexagonal prism, keeping the resting it on corner. Corner should be on the right side. So front view, top view, let's start first drawing by drawing the top view. So like the previous problem, A, B, C, D, E, F is seen, A1, B1, C1, D1, E1 is not going to be visible. So just drawing hexagon. So we are going to sketching. So initially I am going to draw a circle, which is radius equals to side length. Here the side length of the hexagon is 25, so I am going to draw a circle. Radius is going to be 25. Now we are going to rest it on corner. First thing is I am going to draw the diagonals. So from here I'll take the compass, I'll take a radius of the side length which is equals to 25. I'll cut here. From here I'll cut a radius 25. So again from here I'll cut a radius 25. Then I am going to draw hexagon. So from this point, intersection point, so I am going to give its dimension. So I am going to give the dimensions which is equal to side length of 25. Now I am going to rub all these construction lines. Even circle also I will not retain it, I am going to delete it. We need to find its center, so we are going to draw its diagonals. So diagonal should be in thin lines. So this is diagonal which we have drawn just to find the center of the hexagon prism. This is nothing but an axis point. So we can able to see A but not A1. We can able to see the B point but not B1. C we can see but not C1. D we can see but not D1. E we can see but not E1. F we can see and F not the F1. So we are going to get it's even the axis point. This is nothing but O is seen, O1 is not visible. So I'm going to project this lines from A till this point. So all these lines are the projection lines. This is the axis point. From here it is a projection line. We have done it. So it is the resting it on corner. Axis length equal to be side length. Whatever we are going to solving is the regular solids. So the lateral edges and the axis length height remains same. So we have to draw a line which is equals to 50. We are going to draw the axis line. Axis line should be thin line and chain type line. Let's see its annotations. And I'm going to see it from here. A, A1, B, B1, C, C1, D, D1 is seen. So in front view, A, A1, B, B1, C, C1, D, D1 is visible. E, E1 is not seen. F, F1 is not seen. So A dash is seen, When I'm going to see from here, B dash is seen but F dash is not seen, C dash is seen, E dash is not seen, D dash is seen but O dash, which is at the front view, the access point is not visible. So similarly we can go for the bottom faces, which is B1 dash is seen, B1 dash, F1 dash, C1 dash is seen, E1 dash is not seen, D1 dash is not seen. Similarly even the access point O1 dash is also not visible. The next step is we need to tilt it. So what he says is it is on, we are going to tilt. The next step is we are going to be tilting it in with inclination with respect to HP. So here in this case the axis of the prism is inclined to HP at 40 degrees. So before that he says that one of its corner of the base such that two base edges containing the corner on which it rests make equal inclinations with HP. So that is, so it is resting it on corner, we are going to tilt it towards the right side. So when I am going to tilt it, now you can see that it is resting it on corner. So now this hexagonal prism is being tilted inclination with respect to HP. Now you can see that this makes equal inclination with respect to HP. One side is not 30 degrees, the other one is not 60 degrees. It is going to make equal inclinations. So this is what they have mentioned in the question. So by default, whether they are going to mention it or not, we are going to be making it equal inclination, because always we are going to make this diagonal, which is going to be, this diagonal is going to be parallel to VP. So this is going to be making equal inclinations even if you're going to keep it in the top view. So this is make some 30 degrees, some similarly 30 degrees. So this is making equal inclinations. When I'm going to tilt it, it is going to be in, it makes equal inclination with respect to HP. Makes equal inclination with HP. Next is draw the projection when the axis of the prism is inclined at 40 degrees. If axis is inclined 40 degrees, so in question bank he has mentioned 45 degrees. I've just changed it to 40 degrees just to make how this diagram will look, and also how you are going to be drawing when the prism has been inclined to 40 degrees. So if the axis is inclined 40 degrees, that means all the lateral edges are going to be inclined to 40 degrees. So initially I'm going to draw 40 degrees line. The length of this line is 50 and the angle is 4. Now basically what we need to make is the lateral edge and the base is going to be 90 degrees, because what we're going to be solving is the regular solid. So right now if axis is inclined, that means even the lateral edge is also inclined 40 degrees. Now I need to create a base which need to be inclined 90 degrees with respect to the lateral edge. Now we are going to be inclining the base, that is D1, that is nothing but D1 dash to A1 dash. Now I need to find this. I'm going to draw a line of any length, and we need to keep the protractor in such a way that with respect to the lateral edge the base should be 90 degrees. So I'm just going to be drawing a line. So we need to make sure that from here to here this is 90 degrees. 90 degrees. That means base is going to be inclined at 50 degrees. The idea is we need to make the lateral edge with respect to the base should be 90 degrees. It is not that base is being tilted 50 degrees with respect to HP. So now I am going to take this measurement from here to here. I'll take the measurement from here till here. I'll take this measurement always with respect to this. So I'll cut an arc by radius 50, then from this point 37.5. Cut from here. 25.18 is nothing but the axis line from here, which is 12.5. Now we are going to be drawing parallel lines, or else we are going to be taking even the distance. I'm going to be considering from this point to this point. So from here I'll just take the dimension, which is 70.71. So going for arc, from this point I'll cut a radius which is equal to 70.71. So we have just taken it from D1 dash. Now I'll take the distance from D dash. From D dash to A dash, which is equals to 50. Go for arc by center. From here I'll cut a radius 50. So we got this. From here I just draw this line and get it. Make sure all these angles are 90 degrees. Because here we are solving the regular solid. Even here also it is going to be 90 degrees. Even from this point it is going to be 90 degrees. So that is why we have just created it. Now same way we are going to cut an arc here also, if you don't have the roller scale. Otherwise you can just draw lines which is going to be parallel to it. Delete all the construction lines. So I'm going to be drawing a line. So this is going to be axis line, which should be thin line and chain type line. Trim all the construction lines. All the angle is just for your reference, and the degrees what they have given is for the axis of the prism is inclined to HP. So we need to give the inclination for the axis, not for the lateral edge. So I'm going to delete all these construction lines. Now I'm going to write the same annotations. Even after tilting it, the annotations and the view is going to be same. Now we are going to get its top view. So top view is going to be look like this. This is the first step, this is the second step. We'll be able to see two lateral faces and one top face. So here we are going to project the lines first by horizontal projections. So project face by face, annotation by annotations. So I'm going to project the top face. So this is the first letter A, so A is still this point. Then going for the point B, B point is here, so projecting till here. C point is still here. D point is still this point. So I'm just remove all those extra points. Now I'm going to give its annotations. So this point is A to avoid, I'm going to give the annotations now itself because to avoid the confusion. So this point is C, this point is D, this point is E, and this point is F. After creating, let's go for the bottom face. So this point is A1. So this is nothing but A1 point. This one is B1 dash projecting till B1. This is C1. Still this point, D point is here. So next again we are going to give its annotation. So this point is A1, this point is B1, this point is C1, this point is D1, this point is E1, this point is F1. So outer boundary we are going to be always going to be visible. So we are going to be making these outer boundary of this hexagonal prism in thick lines. So go for lines. So I'll join the point from E1 to B1 to C point to D point. This point is E. Then going to this F1, we are coming to this point A1. Next thing is we need to see the nearest point for the observer. So for us the nearest point is this one, which is nothing but A dash. So line joining A dash to B dash, A to A1 dash, and to this point, which is nothing but F point, is going to be thick line. So this is point is A to B is thick line, A to A1, A to F is going to be thick line. The farthest point for an observer is D1. So here this is the point which is farthest point, which is nothing but the resting point. In the top view, this point is the farthest. Line joining these points is going to be in hidden lines. So here we are going to be making a thick dash type line from D1 dash. We are going to be joining till this point E1 dash. So from here C1 point, E1 from here till this point is going to be dash type line. Now you can see that line joining D1 is everything is in hidden lines. So we are going to keep this inside the bracket. Now even the same way C1 so for this point, the second farthest point for this below this axis line, so this is above this point, axis point. So the top face is seen. Now here we will be able to see these points, but the line joining the farthest point, which is nothing but the point which is this one, this edge, this is nothing but edge which is inclined 30 degrees. So this point is not visible in the top view. Similarly, this point is also not visible in the top view. So now here the second, this is the first farthest point, the second farthest point is C1 dash, E1 dash. So that one is also going to be E1 to F1 is a dotted line, but it is going to be dominated by thick visible edges, that is nothing but F to F1. Similarly, E1 to E is again the hidden lines, but again dominated by the top face. F to E is a visible edge. Now we cannot represent those dashed lines, but we can represent it by keeping the annotations inside the bracket. So C1 will also be inside the bracket. After drawing this, we are not going to overlap any of those annotations. We try to avoid as much as possible. Now we are going to project the axis lines. From here till this point, from here till here. Axis line is a thin line which is of 0.13 thickness, and hidden line is the dash type line, but it is going to be 0.5 thickness. So from here till here axis line is there, but we cannot represent the axis lines. So instead we can just represent the annotations here. So this point is O, and O1 is not going to be visible because the bottom face itself is not visible in the top view. So this face is not visible in the top view, so we are just going to be keeping the O1 inside the bracket. So next step is the same axis E is inclined 30 degrees with respect to VP. that means true inclination with respect to HP. So like how we solve the pentagonal lamina with respect to VP, you can just same the reference. It is nothing but with respect to the first step, we are going to be inclining the axis at 30 degrees. Now we need to find the apparent inclinations. So third step is inclination with respect to VP. Here he has given the true inclinations. We need to find the apparent inclinations. In the previous problem, pentagonal problem, what was given was the top view of the axis inclined. That means this top view is inclined, means he has given the apparent inclinations. In the first problem, the resting edge was inclined. So now I need to draw these lines. The inclination of this is 30 degrees with respect to VP. So we are going to be drawing 30 degrees line. You need to keep enough space that this solid we are going to keep it here. So now I'll go for finding the true length of the, so we have to find the true length of the so we know the true, what the, he has given the true inclination of the axis which is equals to 30 degrees. So we know the true length of the axis is 50. So I'll go for arc by center point from anywhere on this point. Make sure that if I'm going to keep O, this you going to have the sufficient space and it should not even touch the XY line. So from here I can just keep it here, O point, so D will be here, somewhat E and F will be here. It should be first point. We need to keep it based on the assumptions, based on how you're going to be accommodating this solid over here. So I just can keep some point here which is nothing but O point. So O2, O1 is nothing but the true length which is equals to 50. I'll cut a radius of 50. Then I'm going to draw the locus line because I need to find the apparent length of this. I need to find the apparent inclinations. So from here to here, which is nothing but 38.3 is the apparent length of the axis. Here it is 50. So I'll go for arc by center point, move to from here with the compass. I'll cut an arc of radius 38.3. So now I'm going to be drawing this line from here till this point. So this angle is nothing but the apparent inclinations, so which is nothing but beta value So now we found the beta value which is equal to 41 degrees. So this is what beta we have mentioned in it. Now I need to be drawing this entire solid here. So initially we are going to draw the face, then the lateral edges. So now I am going to take, this is nothing but the point O. So this is nothing but the point O. I am going to find the distance from O to E distance. O to E distance will be equal to O to C, will be equal to O to B, will be equal to O to F, because we are solving the regular solid which is equals to 23.13. So with the same radius I'll select this point. So 21.23. 23.13. Now I'm going to take the distance from O to D, O to A, O to D1, O to A1 distance from this point to this point is nothing but 16.19. From this point to this point will also be now I need to find this distance also. It is going to be uniform same only if it is 45 degrees, otherwise this distance is going to be different, which is 23.05. so I'll just go for arc by center point. So 23.03, I'll cut an arc from here. Now I'm going to find the distance from here, which is equals to 15.91. From here till D, what is the distance? 22. From here axis point is 33. From this point it is equals to 54. This is just for your reference. After that this is going to be deleted. So go for the arc. This is nothing but the point O. O to A is 15.95. Then from the same point from here to D1, which is equal to 22.12. So from O to O1, which is equal to 38.3, which is already we have cut an arc because on the locus line. Then I'm going to be drawing extending beyond this, because beyond the O1 point we have the A1 point. So from here, which is equal to 54.26. So again arc from the same point, I'll cut 54.26. Now let's finish the top face. From A to E is what is the distance. We have taken the distance from O to E, O to F, O to C, O to B and cut an arc. O to D is 16.9 here. From this point 16.19. Now from the A point I'll take this distance from A to E distance will be equals to A to C distance. From this point I'll cut an arc of 32.4. Then I'm going to take the distance from A to F, just 23.09. Now I'm going to be joining those points. So this is the point. Join it here. From this point. So we'll just finish the top face. So let's write the annotations. So this point is A, this point is B, this is C, this is D point, this point is E, this point is F. So we are just drawing it on the beta line, which is equals to 41 degrees. Now we are going to be drawing the lines which is going to be parallel to this. So from here I'm going to draw a line which is equals equal in this length, in any length, and this should be parallel to this line. So just going to be drawing a line which is going to be parallel to this. After drawing it, the axis length from O to 1, which is equals to 38.13, that means even B to B1 should also going to be equal to 38.3. all the lateral edges will be measuring 38.3. so I'll just cut an arc by center. From here I'll cut radius which is equal to 38.3 from all the points. So this is the point which is equal to 38.3. so from even here it will cut at this point. Let's move to this point, it's already been cut. So next thing is 38.3 from here, 38.3. Next we can just join the lines. So this is the point. So now we can just draw the lines, and we are going to make this one hidden lines, like how it is seen in the top view. So I kept all the annotations. Now let's draw its front view. So front view should be looking like this. So we just completed the top view, which we are going to be able to see it like this here. Next thing is we have to see its front view. Front view we are going to be should be seeing like this. The maximum number of faces we can able to see is 1, 2, 3 lateral face and 1 bottom face. So here we need to get that view. So we go for projections of this. So first thing is horizontal projections. So this point is A. This is nothing but the top face projections. Go with annotation by annotations, because if you miss any of these points, hexagon will become the pentagon. So you need to be cautious while projecting it. Next is we shall go for the, you see the annotations, this is A dash. If you're just going to be projecting this A1 dash here, it will result in oblique solid, where the lateral edges and the base is not going to be perpendicular. So from A I'm going to project it till this point A. This point is B point, C point is still here, D point projected here, then E point is here, F point is till this point. Let's write the annotation. So this point is A dash, this point is B dash, this point is C dash, this one is D dash, and this point is E dash, this point is F dash. Similarly we are going to project this bottom face also. So this one from here A1 I'm going to project it, then B1, C1. So this is A1 projected to B till this point. That's why we are giving the end point there itself and give the annotations to avoid the confusion. Next thing is B1. B1 is still here. I'm going to be projecting it. Next thing is C1. C1 is till this point, D1 is at the base, E1 is till this point, F1 is till this point. Let's write the annotation. So this point is A1 dash, this point is B1 dash, this one is C1 dash, base corner D1 dash, this is E1 dash, and this one is F1 dash. So the next thing is we need to join the outer boundary of the solid. These are the outer boundary. So go for lines. So I'm going to join this point A dash to B dash to C dash to D dash to D1 dash to E1 dash to F1 dash to A1 dash, from A1 dash to A dash. Now I need to consider the nearest point for an observer, that is nothing but B1. So here in the solid, this point is B1. Line joining B1 to B1 to A1 to C1 is visible edges. So from here, B1 dash to B1 is the thick line. From B1 to A1 is thick line. B1 to C1 is thick line. Let's move to the next nearest point, which is nothing but C1. Line joining C1 which also should be in thick lines. So from C1 to D1, C1 to C is visible edges. So here we are going to be able to see three faces. Here we are going to be able to see here, because of the view is going to be slightly changed because of the change of the angle, because I have not kept it for the beta angle. So this one is, I just kept it 30 degrees by mistake here. So this is the 41 degrees. So there is a view change. So the base is C, three lateral edges is C. So we are going to project the axis line here. So from here, so I just constructed the axis line. So what is retained here is going to be kept. So next thing is, this point is O1 is seen, but O1 dash is not visible. Now we need to see which is the farthest point. The farthest point for an observer is E point. So line joining E must be in hidden lines. So I'll just go for line. So from E point, E dash to E1 dash. So let's go for E dash. So E to E1 dash is hidden line, E dash to F1 dash is hidden line, E dash to D1 dash is hidden line. So that means line joining E is hidden line. So we are going to keep this inside the bracket. Next, let's see that the next farthest point is going to be F and D. So line joining D2 is one is hidden, D2C is outer boundary, show thick line. So D2 D1 comes under the outer boundary, so it is going to be thick line. Similarly, the next point is F1 F dash to E dash is hidden lines, remaining is F dash to A dash is thick dotted lines, from F to F1 is hidden lines. So this is just for the understanding. So we have to keep it above the axis point. So if you're going to see the farthest point above this axis point or the farthest point, if you're going to be keeping it here, these are the first nearest point, second nearest point, third nearest point. Similarly, first, second, third farthest points. So this is how it is going to be seen. This is the front view of these 3 steps, and this is the top view. That is what we have obtained it. Hope you understood the concept and how to solve it. Have a good day.